bringing financial accountability to the variable spend model of the cloud. It's pretty simple. So our journey started about 6 or 7 years ago when we were facing a $15 million upgrade, new data center, new equipment, or go to the cloud. And we decided that we're going to go to the cloud. So we started our journey to the cloud. We started a Cloud Center of Excellence team. Our migrations started to increase, our velocity started to increase, and we started a CCOE. And I joined the CCOE to build the governance plan for keeping costs in control. And a funny story, when I did a draft model of a showback report, and I was showing my boss, and our CEO came by. It was a Friday afternoon. He just walks around campus and says hello to people on Fridays, and he saw the report, and he's like, "You can do this? You can say which line of business is responsible for what costs in the data center?" We said yes, and he's like, "Do it." So that was a vital point in our career, in our journey, in that we had senior executive approval from day one. So that was pretty awesome. We started showing back in 2019, and we showed the business back every month for 2 years, just so they get an idea of what was going to, what their spend was. And we've been charging back or basically invoicing each line of business since 2021. So what does our program look like? We have weekly, monthly, and quarterly kind of milestones. Weekly reporting, we report out on over 150 platforms. We show costs by account, and if we have the ability to show by line of business, we do that as well. We show service cost by account, and then total spend by account on a weekly basis. On a monthly basis, it's more detailed, goes out to a bigger group of users, including senior leadership, so they can see what our spend is. And then we close out each month to create the invoice, and we show platform growth month over month, and just share as much information as we can just to keep the dialogue going of, how much are things costing in the cloud. And this is our holy grail. So this is our monthly chargeback. I know it's kind of an eyesore, but we have 5 lines of business, and this is where accounting takes, that bottom red numbers down there and say, okay, cost center 5, you guys are responsible for 22% of the cloud spend. So instead of IT, which in previous years we were paying all of our compute costs, now all 5 lines of business are paying their fair share. And then quarterly, there's some things I do quarterly. I just take a dump of all the service inventory, or inventory of all services. This may sound silly, but I have used it in the past when teams have I've been tagging my resources forever. And I'm like, well, no, you haven't. And you kind of have something you can go back to and show that they have or they have not been tagging. I've been tracking the impact of our FinOps program since 2020, and here are the numbers that we've the impact that our FinOps program has done using savings plan reserved instances and focused projects to optimize costs. And just some suggestions. Obviously, if you listen to Jay's presentation right before ours, tagging is important, very important. Take advantage of savings plans and reserved instances. Consistently report, celebrate the wins, talk about the losses, if you will. Schedule optimization days with architects. Invest in tooling. We use Cloud Health and Cloud Checker, but there's a bunch of them. There's ways to get those tools for free, so see me after if you want to learn how to do that. and also use tools from your free tools from your CSP, like Cloud Optimizer, which we're going to kind of dive down, taking a deep dive with Pat. So, Pat.
Pat Davies from Direct Supply. So I'm going to get into some right sizing, but first, don't forget about your discounts, deleting things that are not used, and suspending things that are running in the middle of the night that you're not using. That's super important. And the other important thing that right sizing Compute Optimizer is probably not going to help you with is keeping your ear to the rail, reading blogs, and going to Community Day and reInvent. So Rick came back from reInvent, I think in 2022, and said, hey, I just heard that GP2 SSDs are going to be replaced with GP3. They're faster and they're cheaper. So we said, okay, let's find out what we can do. And there was an easy path of converting from GP2 to GP3, which we did, and we ended up saving about $72,000 per year. So don't be just keep your nose in Compute Optimizer for what it can do, but it can't tell you everything. So maybe in the future, Compute Optimizer will help with things like that. So right sizing is configuring or reconfiguring your resources to maximize your savings while meeting your performance goals. So you're going to downsize resources that are over provisioned while still maintaining performance, and you're going to increase or modify resources that are under provisioned to meet your performance goals. So you want to maximize your spend, maximize the value of your spend, and this involves cost and performance both. So it's not always just going to be a savings thing. You're actually going to sometimes find things that need a little boost, and that's not free. One of the problems with challenges with right sizing is data collection and analyzing takes engineering effort, and it's time consuming, and also understanding what AWS resources can help you can be error prone and time consuming. AWS is always releasing new instances, and you may not know what is available out there for you to employ to make things run better or save you money. So wouldn't it be nice if there was something to help? And there is. Compute Optimizer was introduced in 2019, and it's a machine learning service that uses your existing CloudWatch data to identify over-provisioned and under-provisioned EC2, EBS volume, network, Lambda functions, and ECS Fargate resources. Not only does it identify them, but it makes suggestions on what you should do, and it usually gives you a couple of options. So whereas it, like most services in AWS, it has its own dashboard, and it's integrated with AWS Cost Explorer and Cost Optimization Hub. These have to be activated in your account. So if you don't see them, get them activated so that you have visibility to them. Also, you can find Compute Optimizer recommendations right at the EC2 instance level. So in the console, you can, in this case, follow this little orange that's a triangle. It says under provisioned, and it'll give you information specific to that EC2 instance. If you want to look for things on a wider scale, which is what I typically do, in this case, you're able to search, and everybody's favorite region is US 1, Virginia, so I selected that. And then also you can select by tags. And so the talk before us was very timely because tagging is very important, because you'll want to know, if you're going to downsize something, you'll want to know what team that is to tell them, hey, we're looking at downsizing your instances. What do you think of that? And then you can present the evidence to them. So you need a way to find out who is responsible for these servers if you're going to make changes. So the tagging is very important. So in this case, it just came back with one instance for this example. Oops. Current slide. And, good gracious. Okay, we're back. All right, so view the details. And a little banner comes up and it says, Compute Optimizer found that this instance's EBS throughput and EBS IOPS are under provisioned. So this is a case where it's not saying you're over provisioned, that you're going to save money by downscaling, but it's saying your cloud watch metrics are saying that you are not meeting your performance requirements and you should do something about it. So there's a tab where you can select information about the attached EBS volumes. In this case, we have one. And if you scroll over to the right, that'll give you the current IOPS, 3,000, current throughput, 125 megabits. And then if you scroll a little bit to the right, there's recommendations, and it says 3,000 IOPS and 125 megabits per second. And those numbers are the same. It's like, hold up. I thought you said that I was supposed to improve something and you're telling me to do nothing. And I found this peculiar, but we'll get back to that in a minute. So you can scroll down further and you're going to get information about the EC2 instances. And Compute Optimizer typically gives you 2 or 3, maybe it's always 3 these days, possibilities for you to, in this case, improve performance. So we have a T2 micro currently. It's giving us T3 micro, T2 small, and T3 small. And it's giving us the price differential so you can understand what it's going to cost. And then there's several other columns, but one of them that's interesting is the performance risk. And usually it's very low. So you get an idea of what are the risks of changing this resources, and that's very interesting if you're going to be downsizing, because if it says that the risk is very low, that's a good indication that it's worth doing. So in looking at these recommendations, it's determined. So we already saw that it says that IOPS and throughput are under provisioned, and it's recommending that we change instance types. And I can't remember if I forgot this or if I discovered this for the first time, but it's not obvious in the console, but a different instance type can improve your EBS volume performance. A good way to compare performance of different attributes is to go to ec2instances.info, which redirects to the Vantage website, where you can view and compare features of the different EC2 instances. So this example here is the network performance column for each of the EC2 instance types that is on the left. There's all sorts of different columns. These search boxes can take regex, so you can filter on what you're interested in. And so this was telling me, yeah, I could change the instance type and my IOPS and throughput would improve. The other place that I will commonly go for Compute Optimizer recommendations is in the console. You can export your utilization data and recommendations to a CSV file in an S3 bucket. So you can export information from one or more regions. You filter by the resource type, EC2, ASG, EBS network, and ECS. You can select different columns. I just select all the columns and let it rip. And I end up with a giant CSV file with 50 plus columns, hundreds, really thousands of rows. And the account ID is in scientific notation, so that's fun. Now what do? I've just asked for all the information and I got it. So we just did some simple things in Excel to make it obvious what was under provisioned, over provisioned, so we could just see better what was going on. And a handful of them looks like we got right, optimized. There's no changes suggested there. So we just flavor it to taste so that we can see what we might want to do. One of our use cases when we got into Compute Optimizer was we suspected that Windows instances with 2 CPUs or 2 gigabytes of memory were a bottleneck during our patching process. We wanted to identify these instances and determine the cost to bump up the CPUs to at least 4 and at least 4 gigabytes of memory. So from that data that I got, just use some standard Excel tools, array formula lookups, as well as other things, to determine which EC2 class we'd have to go up to give us at least 4 gigabytes of memory and 2 CPUs, because we know that you can't take a T2 micro and give it 64 gigabytes of memory. You have to do something else. So this helped us understand what that would look like as we change instance types to improve the CPU and memory. So this got us a current, an hourly cost estimate. And in these servers that we had selected, the ones that were subject to the patching, it was about $17,000 a year was the run rate. If we just went and updated the CPU and the memory, the instance types to get that, our costs went up to $31,000 a year, 85% increase. Didn't even bother to tell anybody about that because it's not going to fly just for patching 8 nights a year. We looked at what would it be just to up the memory, and that was a little more palatable, 20% more. In the end, I think we just actually upgraded a few of them, but nonetheless, we learned a lot about Cost Optimizer in the process, and learned a lot about what our environment looked like from that spreadsheet. There's all sorts of good information. So not only is it a good place to find recommendations, but that spreadsheet just has tons of information that you can glean out of there and manipulate in Excel. There is also Compute Optimizer for Lambda functions. So it identifies which are CPU intensive versus memory intensive. A Lambda function that uses a little bit of CPU but over-provisioned memory is just wasting money and should be adjusted. Reducing the memory just saves money and won't adversely affect performance. You can also have a CPU-intensive Lambda function, and the recommendation is to increase memory. And that will increase your costs, but the runtime will be shorter, so you'll be paying about the same amount of money, but a better performing Lambda function. So the components, which I've kind of been through already, CPU memory with monitoring enabled, by the way, network performance, storage, IOPS and throughput, auto-scaling groups, and Microsoft SQL licensing, which is relatively new, and I'll get to that in a moment. New since reInvent 2023, improved dashboard. It really looks nice now. It shows an overall view of your instances, auto-scaling groups, all those things I just mentioned, including the Microsoft SQL database workloads. And just as a reminder, you need to activate this in your account to start to see this information. Also, there is the option of filtering on EC2 type recommendations. So you can, if you have something against the T3 class, you can unselect those and it won't consider those for giving you recommendations. But I would recommend just running it once with everything selected, and then after that, maybe getting rid of ones that you don't want to consider. You just don't want to restrict cost. You don't want to restrict Compute Optimizer too much. You want to let it be able to do its thing. Another new feature is that CPU and memory thresholds are now a little bit tunable. And also there's now a 32-day look-back period. It was previously 14. This is the free tier, that is. So now for free, you can at least get your monthly pattern captured. You can pay for 90 days or 3 months of data, but now 32 days is free, which is useful. The CPU threshold is conservative by default. You can have it be a little bit more conservative or a little bit more aggressive. Same thing with memory. If you want to roll the dice a little bit more and just try to see if I can get by with less. You can tell Compute Optimizer that don't be quite so conservative. Give me some recommendations based on something a little more aggressive. Same thing with the memory headroom. Conservative by default, 20%, but you can be more aggressive or conservative there. Also, some new features that were announced in 2023. If you're into GPUs, there's optimization recommendations available for that. They work best at high utilization. It uses the NVIDIA CloudWatch agent, and you still get the CPU memory, etc. as recommendations alongside the GPU recommendations. Microsoft SQL license optimization is kind of new, and you set it up to spy on your Microsoft SQL environment. It looks at what you're doing, what operations you're doing, and it can make a recommendation on whether you can downgrade your SQL license. So maybe you're running enterprise, and then after a month of data, it says you've never used an enterprise feature. You could go down to standard. And then also outside of that, you could be in a situation where you could need fewer CPUs, and that could also make your licensing cost lesser if you're paying per core. I think everybody does, but I'm not confident about that. And then AWS is always adding new EC2 instance types, and those get supported by Compute Optimizer. So some tips, I think I've mentioned this, has to be enabled in the console. Uses the last 32 days of metrics for free. Expanding to 3 months incurs a cost. The memory metric is not available by default. You have to have the CloudWatch agent. You can also use Datadog, Dynatrace, and New Relic to get that information as well. And tagging standards, again, super important. You need to understand what it is you're optimizing, who's involved, who's responsible for that, so that when you're going to do these things, the right people are involved and aware of what you're doing. And recommendations by Compute Optimizer are refreshed daily. The analysis takes into the account that you may have very high CPU times during the month or during the day. It's not just taking the average, so it's a little bit smarter than that. So you don't have to worry about it making mistakes with just averages. It's actively developed. Like I said, there was new features in 2023. I suspect there'll be more this year. So there's a link here to what they are up to currently. I guess that's it. Are there any questions? Yeah.
Yeah, you mentioned right sizing, and in particular downsizing. So are you guys actually the downsizers, or like do you have to work with, like for instance, a team that's building an app? I would think maybe they want to have a say.
Yeah. So just. The question is basically when we're looking to downsize or we're working with a team to make that happen. Yeah, there's.
Yeah, do you actually?
I'll actually may do the downsizing, yeah, but it's after reviewing with other people. It's like I can't do it in a vacuum. I can't downsize it and then have an outage at 1 a.m. So yeah, we're pretty careful with that. And the glorious thing about that GP2 to GP3 thing was that there was no downside. We didn't even have to tell anybody. We just did it. But for CPU and memory, yeah, we're going to say now I got to convince them this is what we found, and it looks like it's going to work. So. And they'll get their blessing first. And that's why the tagging is super important. Yep.
So you mentioned tagging a whole lot during this presentation. I'm just curious, what kind of requirements do you have for your tags, and then what kind of automation do you have to enforce tagging on different resources?
Okay, so what do we have automation or enforcement of tagging on our resources? What type of tagging do we do? Sound right? So we're tagging on typically business units, the team that deploys it, which includes the email, the platform. It has some FinOps type stuff. So we deploy everything via Terraform. So we actually have a tags module that people are supposed to use, and you have to put in these tags in order for it to get deployed. So that enforces that. And then there's also Cloud Checker, whatever looks for things that are not tagged. And then Rick shows up at your office and says, dude, you're not tagging this right. And they say, oh, I forgot to use the tags module. And then they get that in place, and then the tags are correct.
Yeah, because you can always have older versions of the Terraform that don't make you tag. So that's why I run the quarterly reports, and I see all the, every instance I have, what tags there are. And if there are no tags, I go to the I normally know who the system is. I go to them and say, you're not tagging. You got 2 weeks to tag, or you're going to get in trouble.
Do you guys ever consider using pre-checks before deployment process
I don't know if we've done. So are we doing pre-checks before deploy on tags? I don't know. Dave, what do you think? Yeah, we are doing that.
Yeah, so we use AWS Cloud Custodian, and if things don't meet our tagging standards, then they get crushed within 10 minutes of being deployed. We also have made it a really low barrier to entry for infrastructure as code, and we have a very easy copy-paste tagging standard that should take any intelligent person less than 60 seconds to bake into any project they're deploying.
Yeah, it's really simple with that module. It's there's no excuse for not doing it. So, yeah, I didn't know we were enforcing that. I mean, it's never caught me because I'm always using the module. So, yeah.
Similar question about your enforcement. I think for Rick, you show up and intimidate them, and then it sounds like you crush it after 10 minutes. Do you have any other levers to pull to make people do what you want?
So do I have any other levers to make people do what I want? Cloud custodian is the big thing, but a lot of times it's like, you know, are you using this version of Terraform? If you're not, you're getting by. Your system's getting deployed without tags. So the hammer I use, I guess, is talk to them, say, hey, you're not being tagged. We need to have our costs go to the right line of business. And did you know our CEO really cares about this? I mean, I have done that before, and when they hear that Bob, our CEO, is important, it does it. It's executive buy-in. You always hear that, right? You got to have executive buy-in for your FinOps program. We have our CEO that loves it, so you just tell him, Bob really likes this process and procedure. Please do it, and they do it.
The monthly chargeback invoice that you showed previously, is that generated programmatically, or do you guys create that by hand?
Unfortunately, it's created by hand because a lot of our systems are used by all lines of business, and the calculation that I use to create that is like an agreed upon thing that you can't really program it. You probably could, I guess, if you put a lot of effort into it. It's just easier for me to put it together. I got all my spreadsheets that have the percentages and stuff. So that report takes about an hour to create.
Yeah. What about data transfer charges going between regions?
So we call that a landing zone. We call it like cost of doing business. So anything that's in a landing zone, I say is like you're going to pay your percentage of total consumption in AWS. So if you are line of business B and you use 12% of the whole AWS bill, you're going to pay 12% of landing zone charges. So there's probably 20 different services that I call landing zone. I group that all into one container. So if landing zone's 50,000 for the month, you'll pay 12% of that.
Got it. But can you reduce those charges?
Can I reduce them?
Yeah.
We can optimize them, but they're generally landing zone things are, it's like DNS. It's like transfer fees between different zone, things like that. So yeah, you can, but it's kind of up to the lines of business to do that.
But you might detect if there was a big spike in transfers, right? Yeah, so if it's just humming along at some number, then it's fine. But if it goes up 100% one month, then it's like, well, now we got to figure out why this happened, who did it, and if that's normal. Yeah, so Rick does a lot of that. He finds the spikes and says, we got to look at this. So it's very helpful. Everybody should have a Rick Miller on staff. Anybody else? Oh, we're just at time. Thank you.
We're not doing the Zoom call anymore, right?
I didn't join, right?
All right, cool.
Didn't
I
think
saw
of
it got
yeah.
removed from the. Are we doing the Zoom call or?
This one's automatically recording.
Sweet.
Just plug in and you're on that.
Sweet.
Did you want a quicker
There's one in another room.
I'm fine, just chilling. It's not super crazy. Give people a minute or so to trickle in and out. Give people a couple minutes to come out of the other ones. If anybody wants to join, then I'll jump on into this. Got 3:59 on this clock. Travis is sitting there. Oh yeah, good. All right, looks like we got some people coming in now. Can everybody hear me with this microphone? There's a big sign here that says not to move it, so if that's the case, I can use the hand mic if you can't hear me. Good? Cool. Nobody answered. All right, I'll get us started then. I know this is the last session of the day, so I'll be the last one to welcome you here to Community Days, and I'm the only thing standing between you and a happy hour or your own home, so I'll try to get this as quick and as detailed as possible. So, I think all of you, I want to ask a question before we start here that you might have never thought about, depending on your role within your business, but once you're told the answer to it, you might go crazy, and that question is, we have how many documents within your business? So today we're going to be talking about some architecting modern document processing. There was already a great talk today on IDP from more of an AI perspective. I'm going to focus a lot on the infrastructure here and the tools that Amazon provides for it. So the agenda today, just going to do a quick little about me section, talk about the different technologies that go into IDP, that being optical character recognition, NLP, and then natural language processing, and then IDP being intelligent document processing. Talk a little bit about why you would even want to do this. Talk about the tools that Amazon provides to actually get this job done. Cover a couple of sample architectures I've worked on, and then we'll go through a really simple extraction demo using invoices that I've made up to really show off how this can function for your company. So just a little bit about me. My name is Drake Pisacco. I'm a senior consultant here in Columbus with Slalom. Slalom, just a quick about us, is we're just a next generation professional services company. This is directly off our website. If you want to learn more about us, feel free to go to our website. I've got a bachelor's in computer science from Ohio State University, a bachelor's in physics from Washington Jefferson College just south of Pittsburgh, which is where I was born and raised, and I've been in Columbus for about 8 years. You can see here over on the side, that's my family, my wife Lauren. It was our 6th anniversary this past Sunday, and my 2 dogs, Badger and Pooch, and our cat Fry. So, what are the underlying technologies that actually enable intelligent document processing? These are all definitions pulled directly from AWS's website, so if you want to learn more, there's links provided in the deck. For optical character recognition, known as OCR, that's the ability for software to actually recognize characters in an image or some kind of document and convert those into computer-readable text. We've had OCR for probably way longer than you think. The original OCR softwares were just sort of light pens that you would drag over documents back from in the early 50s, and then it's translated into what we have now, where things with Amazon, you can just upload documents or even just take a picture with your phone and have that just turned into actual structured data in some form. What you can then take with that and actually use is the natural language processing. So say you've got a PDF that's got all these things and you just want to know what the sentiment is. That's where natural language processing comes in. It's a machine learning technology that actually gives computers the ability to interpret and manipulate and comprehend human languages. So things like I had mentioned, like sentiment analysis. Are these emails you're getting, are they positive, are they negative, are they mixed? Detecting what type of language a document it is in. We talked with Darko today, who's from Serbia, who's talking about different results not getting great from Serbia, so maybe a Serbian document, you don't even know what language that is. NLP would help you be able to detect that when it comes in. And when you put that all together with any kind of like sort of other downstream processing, you've got intelligent document processing. And that's just automating this entire pipeline process of taking this manual data entry from paper-based or image-based documents and integrating that output structured data with other digital business processes. So that sounds great. That's all a lot of cool jargon and buzzwords. Why do you want to do this with your business? So a client that Slalom worked with, this was actually my first client with Slalom. I worked with them for about 2 years directly. We'll call them Z. They're a national healthcare payer operating in 48 states. They're a Fortune 100 company. They still use paper documents equivalent to petabytes of data each year, numbering in the billions of individual pieces of paper. And to process all of these documents in all these different states, they have to hire contingent workers to adjudicate, process, extract from all of these documents. There's a huge variance across all these different types of documents, and then also within individual document types, there's variance across locations. Let's say you've got a contract with a healthcare provider in the state of Texas. That's not going to look anything like an explanation of benefits for a member of this healthcare payer in Maine. They are entirely different. You need to have entirely different groups of knowledge to process those. And with these groups of contingent workers across their entire business, there was no kind of templatizing, there was no kind of documentation. It was all based around tribal knowledge where these little groups would come in, analyze what they had to, and then they would get out. Sounds great, doesn't it? No, it was awful. And the people didn't like doing it, and Z didn't like spending the money on it. Let's look at how the IDP solution that we brought to Z actually improved what they were doing. Here's what it took them to manually process one contract, which would average about 40 pages with the states that we were starting with, which we started with Texas. It took about one contract for one human, one entire day, to extract the necessary information, being who signed this document, who is it with, what's the tax identification number. There was a huge list of fields that needed to be pulled from these contracts. And on top of that, for every contract coming through, there's a between 1 in 4, 1 in 5 chance that it's going to have to go through somebody else because somebody got something wrong. And that's just adding more time to this, so you're getting 1 in 4, so day and a quarter, day and a fifth to actually really process this when it comes down to this. With IDP, once we gave them this automated solution, they're processing 50K contracts every single 8 hours with this IDP, and they've got that reprocessing rate down to 7%. 7% being, hey, we've got this document, we think we found the tax identification number, we think it's on this page, can you have a human do this? So when we output this information into a DynamoDB table, we would leave a list of flags saying, hey, this item needs human review, here's the page we think it's on, here's the value we think it is. So not only are these people getting a document that is either good to go, but when they're not, they know exactly where they should be looking in general to start their process of troubleshooting this and looking for where these values might be. So just an absolute huge improvement. Z was very happy. They've expanded this for many times ever since Slalom has moved on from this engagement within their internal teams, and have loved building on top of this. So, cool. How do we actually do it now? We've seen what the outcomes are. Let's build it. Amazon's two main services for this. You've got for OCR, Amazon Textract. For NLP, you've got Comprehend, and then a sort of sub-service called Comprehend Medical, which is more geared towards doing this with medical data. So Textract is, again, the OCR tool here. It has a whole lot more features than just this. This is not comprehensive. When I started working with Textract about 3 years ago, on this list, the only things it had available were form recognition and table detection. So all of these other features are new, and they're adding more and more all the time, especially now with generative AI coming out, they're even building in with other services. So with form recognitions, let's say you've got an invoice, and towards the top of that invoice, you've got a section for address, you've got a section for date. It'll actually return that in the JSON as a key value pair that then you can access here. So you'd see it would show up with JSON, not literally like this. The value within the overall JSON structure would look like this, but I've got Python brain, so I'm going to talk about things like their dictionaries. It would be something like this. Additionally, you can do table detection. So still with that example of an invoice, or we could talk about something like an explanation of benefits where you've got this table that's listing out things, different columns, different values. With the tables, it can actually detect and load those tables as individual table objects that you can then just upload directly into whatever database schema or structure you have. Or if you're using Python, like I love to do, you could even just pull that right into a pandas data frame and interact with the data in whatever kind of processing you're doing. It's also added new features like signature detection. So with signature detection, it's telling you the bounding box location and the page number of where somebody signed something was, and you can see exactly where that is. If you pull it up in the Textract console or at a front end, you can actually even highlight exactly where that signature is to validate that it's a valid signature. Textract also now has support for all sorts of identity documentation right out of the box. So let's say you've got an Ohio driver's license, or you're some company that needs to connect driver's license information. Somebody uploads a scan, you throw it through Textract, it knows exactly where to find anything. You don't need to add anything additional to what Textract has to get the end results that you want. And then a newer feature of Textract that I sadly have not had the chance to use yet, but I'm really looking forward to use in any future IDP projects I worked on, is queries and custom queries. This basically just lets you ask Textract, when you submit a document in plain English, hey, what's the patient's name on this explanation of benefits? Or, hey, what's the due date for this invoice? And based on what Textract pulls out, it can give you that information, and you can access that as part of the output JSON. It'll have the answer to all your queries in the JSON. Additionally, you can train custom queries using things called adapters to sort of expand what Textract is pulling in and figuring out from this data to ask it questions that it might not be able to otherwise understand. I've yet to work with custom queries or queries yet, but based on the research I did for this talk, they seem very powerful, and I'd highly recommend doing some more research on your own if you're interested. Now we can talk about Comprehend and Comprehend Medical to do that second step of an IDP pipeline. This is where that natural language processing comes in. So you've got this big bulk of structured JSON data now. You can get rid of your images, and your documents don't actually get rid of your source data. So you've got all your JSON here. And then you can, what do you do with it now? It's great. I've got structured data. You can do things with Comprehend Medical and Comprehend right out of the box, like entity recognition, where you can just have it detect PII and PHI entities and tell you here in where list out all of the entities that it found. You can even create custom entities. So let's say you were looking specifically through news articles and you want to identify all of the mentions of public officials. You could provide some kind of custom entity recognition to recognize public officials like Governor Mike DeWine or whomever you'd want to talk about. It could be recognized. You can also do custom classification. So let's say you're a company who's taking in a lot of emails from customers, but you've only got sort of one email address and you want to know where to route these things. You can bring that in and have things like customers who want to know, hey, I want to know about my appointment information. When is my next appointment? Or hey, who do I make my bill to? Using something like this, you can customize those based on your custom needs. You can classify them and actually have them go off to whatever party needs to do those, or then you can analyze them further from there. It also has sentiment analysis and language detection, like I mentioned earlier. Those are two of the bigger and more common features of NLP software. And like I mentioned with Textract, there's a lot more features in this, even more so for Comprehend. The list is ever growing, and it can do a whole lot more than what I'm mentioning just here. Now, let's actually look at these being put together with some other AWS services to make a real application that can actually parse your data. So this is my first stab at ever making an IDP application. This is very simple, just very simple. If you were in the other IDP event today, you probably saw a very similar architecture. Basically, you've got your documents coming into an S3 bucket. That S3 notification then goes into an SQS queue for scalability. That triggers this intake function, and that intake function takes the event, parses out the location information of your document, and sends that over to Textract. If something were to go wrong there, we'd send a notification to whomever's responsible for managing this service. And then once Textract's done, it integrates natively with SNS. So as soon as if you're running an asynchronous job, you provided an SNS topic and a role that has access to that, it'll publish a notification when the job is done, be it success or failure. Once that's done, send that message into a queue again for scalability. Then we get to this merge function. What the merge function is, when Textract writes out its JSON output for an asynchronous job, for larger and more dense documents, it breaks those up into a number of JSON files. It breaks up the content into things that it calls blocks, and each JSON file can only have 1,000 blocks. So once you hit that, it'll make another one, and they're all just numerically iterated 1, 2, 3, 4 in an S3 bucket in a folder that's got the same folder name as the job ID for Textract. So this merge function goes in there, takes all those blocks and put them into one single JSON function that allows JSON file that allows you to interact with all the data in one place instead of having to load all these different files every time you want to actually do any kind of processing. Once that's done, we send that to another S3 bucket, got another event here in the queue, and this is where the great modular part of IDP comes in. Once you've done that, you now have structured data. You could do whatever you want with structured data. I'm not a data engineer. I'm not a data scientist. I don't know what to do with structured data, but I've worked with this before and I know some things that I have done with it. So we've got this module here that this could be anything. You could feed your output into a Bedrock model to ask it questions about things coming in. You could feed this into into NLP, like we were mentioning, like I mentioned earlier, and you'll see in the next sample architecture. You could also even just do a simple extraction using a Lambda function like we'll do in the demo today, where you know exactly that all these invoices are going to have the exact same format. We know we're going to find this table, let's interact with it and get exactly what we're expecting. There's all sorts of different modular things that you can plug and play in with this OCR workflow to make it a full IDP pipeline. Now here's a bit more of a complicated example, but it's still really not all that complicated. If you look closely here, this was a project that we did for a public sector client who needed to redact pretty much every document coming across the governor's desk through the entire state. At the time, they had a single state archivist doing this manually, taking PDFs, taking scans of parchment from years and years ago when the state was first founded, and having to redact things. All of these things were a pain because she still had her original archivist job to do on top of that. So what we built for them was a front end, just a nice little web app for her to go in, upload documents, have them processed by Textract, and then she would get back a PDF or whatever file type that she originally uploaded with black bars drawn over like a fun secret agent document over all of the PII and PHI in these documents. But you'll see after we got to that web application, you're starting to get a really similar architecture here, where you go down to this S3 input bucket, to a queue, to a Lambda, to Textract, S&S, SQS, Lambda, bucket. It's the same. The first half of this is the exact same. That NLP process is that simple. And there we can plug that into whatever we want. In this case, we plugged it into a step function that takes that data, we prep it for comprehend, because comprehend in this case was working on text files since it was doing entity detection. So we've got this prep function to do that, and then we check to see if there are available jobs, because comprehend only allows 10 jobs at a time, but those 10 jobs you can have, I think, like thousands of documents in a singular job. But this is just this was an MVP project, so we were just doing one document, one job at a time. So we're iterating, checking for job availability, getting that job availability. Once it's done, we submit, then we're checking in on job status. Is it done? Is it done? Has it failed? Whatever. If it's failed, we go into our failure workflow of notifying whomever, sending the document off to manual review. But if not, there we have the redaction function. The redaction function puts all of this together. It pulls back in that original document from the first S3. It pulls in the Textract output, since the Textract output contains location and bounding box data for all of the things within the document. And then we take the entities that were actually discovered by comprehend. Then we iterate through the Textract to find any of those entities. If we find one, we get that bounding box information, and then we would redact over it in the PDF using a C# library that I do not remember the name of. But then once we were done with that, it would get put out into an S3 bucket, and that would be reviewed by the archivist. If she was happy with it, it went off into whatever deep storage they sent off all of their archived documents in. And then using S3 lifecycle policies, eventually they left the S3 and only lived in the deep archive. So that was a lot, and I am a notorious fast talker, but let's get into the fun part, which is the demo. So this demo is going to be the first half of it, first 90% of it is going to be exactly what I showed in that demo, where you've got this Textract caller function. Oh, I'm not sharing anymore. Let's see. Just get back in there. Always fun. Oh, here we go.
Oh, it's again? Okay.
Cool, we're good. Perfect. Live demos, love it. So I wrote this in AWS SAM just because I've done this so many times with SAM. I could probably do it in my sleep. You could do this with CDK. You could do this with Terraform. You could do this with custom CloudFormation. Not the point of this. But basically, we're just creating all the infrastructure that we need here. We've got our caller function here. I won't go too deep into the IAC. You've got the merger function that I mentioned. And here we've got this parser function. What the parser function does is we're taking the data that's coming out of Textract that, since we know what the exact structure of this invoice is going to be, we know every time that we can pull from the table, we can find the row we need, and we can get that information without having to worry about it. In addition to that, we're making our source bucket, our output bucket, the SNS topic, a role for Textract, and a Dynamo table to store all of the job statuses and then also output the information that we actually pull from the invoice. This here is what our invoice looks like. Just a simple invoice from IDP Consulting here. They're charging a lot of money to do manual data extraction. And what we're looking for is to just get the total bill out of this and how much we actually owe to IDP Consulting here. So we can come back to here. I've got my Community Day source bucket. Upload. Add file. Invoice. Open. Upload. So here we go. It's going to kick off. You'll see that our output bucket here, oh, that was the output bucket because we're good. I had source open twice. So we've got our output bucket here. So now you see we've got this raw Textract output. Since that was a pretty small file, we're only going to have that one JSON. So we'll click into the job ID here. We've got, here we go, 1. And if it was bigger, there'd be 1, 2, all the way through however many you need. It could be hundreds. I've never had more than 100-ish, but I've also not uploaded an entire novel before. So who knows how big it can actually be. Hopefully Amazon. And now the merge function will have run in the background here, so we can actually check this merged output here. We come in here, same thing, job ID. We've got a folder for the original file name, so that's not lost. And then we've got this output.json. In this case, it's going to be the exact same that 1 was, but in the event that we had more, there would be this output.json that is the accumulation of all of the other JSON files. Then we can come over to our Dynamo table here. You'll see there's currently nothing in there, but if I give it a refresh, we should have our item here, which, sure enough, we've got the file name being invoice.pdf, the total invoice amount, 1125 that we saw, the actual Textract job ID, the current job status, and then just the output file key of where to find that. That's everything I had for today. We've got about 7 minutes. Does anybody have any questions?
How do you point to that particular value as that is what?
Yes. Yeah. So let's take a look at how we actually worked with this. I'm glad you mentioned that because I forgot to talk about it. AWS provides a Python library called the Textractor. Textractor is a gigantic library that allows for the obfuscation of not only parsing Textract output, but also invoking Textract for synchronous jobs, asynchronous jobs, using different APIs through Textract. I'm currently only using it to process the output, but if you'll see here, let me zoom in just a bit. So I'm getting in the document class through the Textractor. So I'm first downloading that output.json file, and then I'm opening it as a document object. And then within that document, we know that there's only going to be one table. In that one table, we know exactly what we're looking for since this is a standardized form. We then do our convert that into a pandas data frame to make it easier to work with. We do some pandas cleanup to get rid of any trailing white space and any empty rows. Then we're looking specifically for where that description column says total. If we get that value, and then we can go in and write this invoice amount into the database by actually getting the amount from that item. And that's what we're doing to actually parse that table. There's all sorts of different entities that you can use to parse things like key value pairs, signatures, layout information. But for this demo, we just stuck with tables. Any other questions? All right. Enjoy the happy hour.